Alright, so this time we're going to talk about significant figures. Significant figures, what they are is they're numbers that are basically important numbers that we can trust based on our measurements. So to give you an example of what this means and what it looks like is, let's say we have a object A. We're going to do object A, it's the white box, object A, and we want to know how long object A is. We want to get an idea of its length. Now, with that, we have two different tools that we can measure object A with. I'll put these right here. All right, we have tool 1, which has markings that are relatively about this far apart, and then tool 2 has markings that are much closer together. So what this comes down into is the idea of precision. If we were measuring with these two different tools, tool 1 and 2, right? Tool 2 would give us much more precision. Tool 2 has less of a rounding difference in between each of its different measurements, right? The amount that I'm having to estimate or round in between these different markings on that specific tool are going to be much less on tool 2 than on tool 1. So tool 2 then leads to be more precise. Now, what precision really has to do with is how many decimal places down, or how many numbers that we're getting from that measurement that are reliable to that last one that has been rounded up. So what that means and what that looks like is, if I give you, let's say, 101, right, and I give you 101 exactly, that's your number there. 101, remember, could technically be, based on how rounding works, 101 could technically be 100.5 that was then rounded up, and I'm actually going to use a green color for rounding. Right. Or it could have been 101.4 and then rounded down. So what that has to do with is that last number right here, that last one, is our last number that we can really trust. Anything past that, we're kind of having to guess. Because based on the number we were given, I don't know if this number after decimal was anywhere between a 5 or a 4, somewhere in between there. So that last number, that last one right there, is the last number that we can really trust, and it's our last significant figure. So this is where the idea of significant figures come into play. Now, actually looking at and trying to determine the number of significant figures can be based on 4 different rules. The rules I'm going to show you right here are just 4 different rules that you can look at on whenever you're looking at a number to see which ones you're given in a measurement. That's another important fact to make. Significant figures only come into play. Figures are only for measured values. All right. For exact values, especially with some conversion factors, and for different numbers such as pi, which have continuing unlimited numbers of values for them, they don't really have significant figures. We don't use them as a limiting number for that. So our 4 different rules are: first rule is any non-zero number is significant. That means any number 1 through 9. Second rule we're going to say is leading zeros are never significant. Right? So if I give you, if I give you 0.00184, these 3 zeros that are leading, that are in front of your first non-zero number, those first 3 zeros do not count. They're not significant. We don't ever want to count those. Because if we put this into scientific notation, those numbers wouldn't be necessary. We wouldn't even need them as placeholders. Third rule we're going to look at is whenever we're talking about captive zeros, right? Captive zeros are always significant. Right? An example of a captive zero would be if I gave you 4,004. Right? Now, automatically looking at it, this 4 is not a 0, so it's significant. This 4 is not a 0, so it's significant. These two zeros that are trapped in between are significant. The reason for that is because if I change either of these, right, this number place changes as well because it's going up by 10. It significantly changes your number there. So these are not just placeholders. They're actual important numbers, so those captive zeros are always significant. Lastly, number 4. Number 4 is trailing zeros are significant if a decimal is present. All right, and two examples for this one, or to show the difference, is going to be if I give you 300 versus 300 with a decimal. All right, the first 300, these trailing zeros, these last places, we're not sure of them. We consider them rounded because there's no decimal there telling us what it ends, so the only significant number here is going to be that 3. So these two are not significant. When you see the decimal, though, that's telling you it's 300 on the dot. This is the last place here. That last 0 is the last one that we're sure of, especially when it comes to rounding. That last value is our last significant value here. Because technically that 300 could have been 300.5 rounded down, or once again 299.5 rounded up. And for this one, I'm sorry, I meant 300.4 rounded down. 300.5 would round up. So these two zeros count because they are relevant to the number. If they were to change, the number would change. So that decimal there tells me it is 300 on the dot. Let's do a couple quick examples. I gave you 4,004, 200,800, 0.000421, and 0.23006. All right. So looking at these, this first one, 4004, this is significant. This is significant because they're both non-zeros, and then these two zeros in the center are captive. So there are 4 Sig Figs. All right. For this one right here, 2 is non-zero, 8 is non-zero. These two are captive zeros. Now, we have 2 trailing zeros, but there is no decimal, so those are non-significant. So there are 4 Sig Figs in this example. For this one right here, we have a 4, 2, and a 1, non-zero, so they're significant, and 3 leading zeros. Remember, leading zeros are never significant, so we only have 3 Sig Figs here. Then we have, for our last one, we have 2, 3, and a 6, which are significant, and then we have 2 captive zeros, which gives us 5 significant figures. Now looking back at that last one again, if I gave you 0.2300600, right, because of this decimal right here, these 2 last zeros would also be significant. They're trailing zeros with a decimal present. So we would have 1, 2, 3, 4, 5, 6, 7 Sig Figs. All right.